Welcome to lecture 4.5. We're going to be comparing major versus minor resonance forms. Depending on your professor, this may be a very emphasized part of the unit, or it might not be mentioned whatsoever. Let's discuss this idea of major and minor forms and talk about the factors we're going to use to determine this. Now, generally, the major form is the best form, the most stable type of resonance. As we discussed earlier, the more stable a molecule is, the more it's going to contribute to the overall resonance hybrid. Typically, if you have 2 or 3 or 4 equally stable resonance structures, then they get to all be major and they all get to equally contribute, like we've seen. But there are many cases where there are resonance forms that really aren't that good. We know that they're not stable, but we're going to explain why. And these are the minor forms. Of course, the minor forms come with different shades. There can be really bad forms and forms that are worse than the major, but not as bad. So let's break down how that works. The 3 factors we're going to look at, ranked from most important to least important, are first the octet rule violations. Now this is only going to really occur with positive carbon or carbocations. And we can see an example of that with this molecule here. Following the resonance arrow that is drawn, we see that the double bond between the carbon and oxygen is breaking, forming a negative charge on the oxygen. And this leaves a positive charge on the carbon. Now, a negative charge on the oxygen might not be great, but much more pressing is the fact that we've generated a carbocation, which is an octet rule violation. So this is certainly a minor form when compared to the major form. The reason why this is the most important is if multiple factors are changed, the octet rule violations will take priority. And you'll see an example of that at the end of this lecture. Now, the second trend is going to be separation of charge. Here's an example of a benzene ring that has an alcohol group connected. Fun fact, another way to name this molecule is to call it a phenyl. Now, if we follow these arrows here, the oxygen is going to be forming a double bond to the benzene ring, and we're going to be getting a lone pair on this carbon. So following those arrows as drawn, we get a molecule that looks like this. Now here, there is no octet rule violation, as a positive oxygen might not be stable, but it does have a satisfied octet, and that is also true with a carboanion. However, one way that we can view this is that this molecule has taken a neutral thing, a neutral molecule, and broken it into a positive and a negative. Of course, this cancels out, but this makes this form the minor form, the less stable form, when compared to the major form. And so we could call that separation of charge. If there was another resonance form that broke the octet rule, that would be worse than this form. The last trend we're going to look at is when we put negative charges on electronegative atoms. So assuming that there is no separation of charge to consider, and there was no octet rule violations, the last way that one resonance form could be better than the other is based on where you put your negative charges. In this case, with this molecule, we have a double bond with an oxygen with a negative charge connected to it. If I follow these arrows, the lone pair is going to form a double bond from the oxygen, and we're going to push this pi bond out onto the atom like so. Now, looking at these 2 molecules here, both of them have a negative charge. However, the negative charge here in our original molecule is on oxygen. Oxygen is an electronegative atom. It generally is more stable with the extra electrons, and that means that this form is going to be the major form that dominates the hybrid, and this form is minor. So with those 3 trends out of the way, let's go through a pretty complicated example that really shows you how multiple resonance forms can be ranked. So here I have made 4 resonance forms of this original molecule, and you'll need to rank the forms from most stable to least stable. So at this point, please pause the video, take a look at these structures, and try to assign rankings 1 to 4. Now, of course, number 1 will be the major form, and 2, 3, and 4 will be the minor forms. Excellent. So if you got it, that's great. If not, I'll walk you through right here. So to start, we can see that this first resonance form has separated a charge compared to our initial molecule. These molecules down here have also separated charges. It seems like there's even more charges. But most importantly, they both have an octet violation, a carbocation. So in terms of the first priority, the way that I would approach this kind of question is to look for the octet violations first. These molecules both have an octet violation, so they're both going to be the most unstable, either 3 or 4. The question is, which one is most unstable? Here, we might look to separation of charge as the next trend, but they both have 2 negative charges and 2 positive charges. So separation of charge is equal. They both have an octet violation, and they both have equal amounts of charge. So that brings us to our last priority, which is, where are those negative charges? In this molecule, we have 2 negative charges on carbons. Of course, this is quite the unstable molecule at this point, but it's illustrative, as this molecule has 1 negative charge on a carbon and 1 on an oxygen, making it slightly more stable than that one. So that leaves us with the remaining 2 structures. Here, there is no octet violation, but we can clearly see that the second molecule has separated charge, whereas the first molecule is entirely neutral. That makes this the major form, and these the minor forms. However, even within the minor forms, we can still have a hierarchy, as this is the second most stable, this is the third most stable, and this is the fourth most stable. I can't imagine a more complicated question in terms of resonance, so this should be pretty illustrative on how major and minor resonance forms are decided. At this point, we're going to be looking at practicing and building these skills with resonance, as again, this is a very important topic.